Hi and welcome to my video course about CDK testing with TypeScript and Jest. We will first see an introduction to Jest testing, and then we will test a very simple CDK stack written with TypeScript. All the source code is in the description of this video. What can you expect from this video? You can also check the video outline, but we will see how we can write declarative tests, how we can use matchers, captures, and even snapshot testing. This video course is a part of a full CDK course. You can also have the link in the description. This being said, let's get to work. In order for us to write our tests for CDK and for AWS SDK, first of all, we need a test runner, and currently the most popular test runner is Jest, but if you prefer, you might use other test runners, even the embedded one in Node.js. We won't use any advanced features of testing like mocking, at least for the CDK part. But in this lecture and in this section, we will use Jest, and what we will do, we will install this test runner, and what is needed for TypeScript, we will configure it in a configuration file, and then we will write and run our very first dump test file to see if everything is working. And when I say everything, I mean the testing setup. Let's get started. Let's install what we need. And in order to do this, I will start a terminal. I'm using the embedded one in VS Code, and we need to install inside our project, first of all, Jest. Then we need to install TS Jest because we are using TypeScript. And again, because we are using TypeScript, we also need to install at types Jest. Wait a little. Well, our libraries are installed. That's great. The next step that we need to take is to configure this Jest testing library. And we can configure it by creating a configuration file. And inside our project at the top level, I will create a new file and I will call it jest config.ts. With the newer version of Jest, we can also write our configurations directly inside a TypeScript file. Well, let's configure this, and since we are using TypeScript, this means that we also get some typings assist, and we will need the configuration object from Jest. So here I'll say import, first of all, from at types/jest. We need an import right here. Well, it's at jest/types, and what we need right here is the config object, because we will use a object like this. And here I'll say const config of type config, and this is the reason I imported this. We need initial options right here, and the last step is to export this default config. So I'll say export default config. Remember, export this as a default, otherwise it won't work. Well, let's write our configuration right here. And the most important configuration inside the Jest is the place where it will search for tests. And currently our tests are inside this test folder. But let's make things more clearer, because there are two ways in which we can organize our code, or our code and our tests. For each file, we can write next to it the test file, or I think a more cleaner approach is to put all the test files inside a test directory. And this is the approach I will take. And another important point, usually it is a good practice for the test directory to also mimic the source directory. This means that if we want to test our infrastructure, our CDK stacks right here, I will create an infra folder inside my test. So here I will create a new folder. First of all, I will call this one infra, and the files inside this test the files inside this folder we will test. So right here I will save this to a constant. So here I'll say const base test directory like this. Let's make this a string, and first of all we need to access the root directory. This will tell Jest to look into the root directory. Then we will go into the test folder, and then we will go into the infra folder. For the moment, we want to test our CDK code. So this is where our tests will live. Right here, right here. Alright, and now we need a preset, and the preset is TS Jest, and this way Jest will know to parse TypeScript files. Remember, have this library installed. Then we need a test environment, and our test environment is Node. Our files are run on the server, and we also need finally a test match. And this is an array, so an array of string, and let's make this a parameter string. And we want to look first of all inside our base test dir, right here, our base test dir. Then we want to look at all the files inside it, like this. We can do it with these keywords, with these symbols. And we want to only use the files that end in test.ts, because maybe inside this folder we will also have like helper files for testing, but we don't want to directly execute those files as tests. Alright, let's see if this configuration works, and let's create a new file right here. I will call this initial test.ts, and now let's write our first test, and we can organize tests inside a describe function. And as you can see, we have the describe from Jest, and we also have a describe embedded in node test. We will use the one from Jest. And here I will say initial test suite. It is better to organize tests inside the described blocks. And first of all, we can now write our first test. I will say right here, test with a callback. This is our tests. And I want to also talk for a few seconds about the structure of a proper test or unit test, but any test in general. First of all, there are three main parts of each test. First of all, we have a arrange step. When we are arranging or we are preparing our step environment, then we also have an act step where we are acting with our classes or our system under test. And then we have a assert step when we are making sure that things are the right way, or if they are not the right way, this step will fail and will tell us that something is wrong. But for the moment, let's simply make an assertion. Here I will say expect, for example, true to be truthfully, something like this. We only want to see if our test configuration works. Let's see. And I can call this with npm test, but first of all I need to add this to our scripts inside our package.json file. Let's add a test script, and as simple as that, we can simply say that for testing let's invoke this jest command. And why is this working directly? If we look at our node modules, because we installed Jest, if we look into the bin entry inside our node modules, here are entries that we can directly execute, and at some point we will have this Jest entry. If you're using Windows or Macs, you will have the entries also corresponding to your operating system. So when we are directly saying a command right here, this command will first look inside the bin folder of our node modules and see if he can find a command right here. Well, we have Jest installed right here. That's great. Let's now see if everything works. npm test. Alright, and our first test works just fine. We have these initial tests. This means that our libraries and our configuration works just fine. Let's move on into the next lecture and see exactly what we will test. Let's now see what we will test inside this section using CDK testing resources. We will test a simple monitoring stack, and this stack will just add an alarm to a metric tied to an API endpoint. Let's say that we have an API endpoint, and from time to time there will be like 400 code events on that API, like not found, like not authorized, and we have a metric and an alarm configured for that API. Well, when that alarm enters into an alarm state, it will send an event to an SNS topic, and that SNS topic will invoke a lambda, which will also at its point will do something else. It will invoke a webhook. This is a very simple stack. We will have defined inside our CDK code this alarm, this SNS topic, and this webhook lambda. And the way I want to use this as a testing purpose is because all these three resources, these three resources that we will test, they are linked to one another. So we want to see, using CDK testing, not only that our CDK constructs have certain parameters, but also we want to test if they are tied to one another. And this will also mean some dynamic behavior inside our testing. Let's look at the code of the stack we will be testing. This is the simple monitoring stack that we will test inside this section. We have a lambda, a very simple Node.js lambda. We have a topic, we have a topic subscription, and with this topic subscription we are making the connection between our alarm topic and our lambda, and we will see how we can test this. And we also have a configuration for a alarm. This is basically what we will do. Let's get started in the next lecture. Well, it's time for us to finally write our CDK tests. And let me start this lecture with a little disclaimer. I've been following CDK since the first days it appeared, and I saw that it is still evolving because it is a new technology. This means that also the way we are writing tests for CDK code is slightly changed. So from this lecture and from now on, I want you to understand first of all the concepts behind the little code that we will be writing. In this lecture, we will make the setup part of our tests. We will prepare the template to test against. In that template, we will also do that act step, which means for us to query for our specific construct. And then we will make an assertion to check if that construct has the properties we want. Well, let's get started, and it's time for us to write a more proper test. And what we will test in this lecture, let's say we have a very simple lambda function declared inside our CDK code. Well, when the code is executed, a CDK or a CloudFormation template is generated. Let's quickly look at that CloudFormation template. These CloudFormation templates are put inside the cdk.out directory, and remember this because this is important. And if we open that generated template, you will see that at some point we will have our construct, which is of type AWS lambda function. I guess this is important for testing because using this construct type, we will query for the whole, inside the whole template, we will query for this construct, and we will assert certain parameters of this construct. You will see many of them are automatically generated, but others are specified by us, like for example the lambda runtime and the handler. We directly specify this, and we can query and make sure that the generated template has these characteristics. And these concepts inside this lecture are available and are the same for any construct of inside your CDK code. I will apply to them for a lambda, but they are the same for any construct you will use. Well, let's get started and let's write our first test. So inside this infrastructure test, let me rename this file, and I will call this monitor stack test. This is a better name. And first of all, what we need to do, if you remember, we need to prepare the template that we will test. So we need a way inside our test to take this TypeScript code and generate a template, but not with CDK synth, with the command that we usually take, CDK synth. This command prepares our template, but we don't want to do this. We want to prepare the template inside the test. Well, how can we prepare the template? First of all, we need an application, because all these templates needs to be tied to a application. So here I'll say const test application is a new app, and the app, the one from CDK lib. This step is important because all the CDK construct, all the CDK stacks needs to belong to an application. But since this is running inside the test directory, inside the test environment, we still need to specify a out dir. Otherwise, it will use something local inside our operating system, and we don't want this. So our out directory should be the same as our CDK out directory. This is the one right here. So our out dir is cdk.out. You know, this is not specified by default inside CDK. If we look at the documentation, the default value is the temporary directory inside our local environment. We don't want to do this. We don't want this. We will use the same CDK out folder. All right, we have an application. Let's now generate a template by having a stack. So here I'll say const monitor stack is a new monitor stack that belongs to this test application and has the name monitor stack. All right, that's great. And now the last step that we need is we need the template. So here I'll say const monitor stack template is our monitor stack. No, it's a special file. A special file came from this CDK lib assertions. So something made especially for us for testing. So we are using this template construct. No, not construct. It's a class. Well, here we will say from stack, and we will pass here our monitor stack. And at this point, we have our template. We can now make queries against it. And usually this is a two-step process. We can query for a construct and assert that construct. But lately, CDK has proposed only one function for both these two parts, for the part of the query and for the part of assertion. And we will access this stack template, and we will call the method has resource properties. And this method also makes the query and also makes the assertions that need to live inside a test. So two steps in one go. So has resource properties, and the first argument to this function is what exactly we are querying for, and we are querying for a construct called AWS lambda function. This is the CloudFormation definition. All right, we have made this query, and now we can specify the properties that we expect this construct to have. Well, what properties do we want it to have? Let's say that we are checking for a handler and for a runtime. Maybe let me put this right here, and it's easier for us to write our code. We want this to have a handler, and this should be like index.handler as a string, and we want a runtime of Node.js 18. All right, let's see if everything works until this point. Let's call npm test. All right, our test works. That's great. Let's also see what happens if you are making a mistake. Let's see if we have a typo or something right here. Let's see what it will tell. All right, the test failed, and as you can see, it will tell us exactly what's wrong. You know, it was expecting for this index.handler, but received index.handler. I love it when we are getting meaningful error messages. All right. But as you saw, we made a lot of steps inside this test. What happens if, for example, we want to look at our stack? Let's see it one more time, our template. And we also want to check, for example, the topic. Right here, we have another construct. We want to check this topic, and we want to check for the display name and for the topic name. What we will do? Well, let's do this also inside this test, and you will see what I mean. Because with this, let's just give these meaningful names to our test. So let's just say here, lambda properties, and this will test SNS topic properties. And what we will test right here, we will test for the construct AWS SNS topic, for this one right here. And we want this topic to have like a display name and a topic name of alarm topic. So a display name and topic name, the same. Just some dump examples right here. Okay, this should be topic and alarm topic. But as you see, there's a lot of repetition inside our tests. Well, what can we do to reduce this repetition? Well, we can extract this preparing part of our tests into a different function. And usually in testing, we use the before all or the before each function. In this case, we can use the before each, before all function, because this way of synthesizing a template might be a long process, and we don't want our tests to be very long. So let's put this step inside a before all test that will be called once before all the tests are run. And what we need outside this function, we need a reference to this monitor stack template. So what can we do? First, we can save a reference to this monitor stack template, type template. This is the one. We have a reference, and now inside our before all function, we are making this preparing step. And now our monitor stack template is generated right here, and now we can use it to make assertions. We don't need this anymore right here. And let's see, okay, let's make everything right, and let's see if our tests are still running. Alright, our two tests are running. This means that our tests are okay, and also the preparing step is working just fine. Let's look at the template and let's see what else we can test. For example, a lot of information inside this generated template has a part specified by us and a part generated by CDK. Well, since we don't know beforehand the value of this generated part, is there a way in which we can, for example, assert only for this part that we know? Yes, we do, and we will use matchers to do this. We will do this in the next lecture. Let's now test how we can link two resources together inside this lecture. Because until now we only tested like declarative approaches, but let's say that we have here a Lambda subscription, an SNS subscription that takes two constructs, an alarm and a Lambda, and ties them together. Well, how we can test this? First of all, let's take a look at the generated CloudFormation code from this subscription, from this simple line. Let's look at the generated template. And as you can see, here is created a CloudFormation construct of type SNS subscription. Nothing complicated until now, but as you can see, this SNS subscription takes a alarm topic reference, and also it takes a webhook Lambda reference. Well, but it not just takes them, it also takes them by the name and also by the generated CDK ID on top of that name. Well, how we can test for this interaction if we don't know beforehand these IDs? Well, one answer, it would be matchers. Another answer would be that we can also test directly with these values. We can get them, and I will show you how we can directly get them. But let's say that we don't know exactly what we will get inside our test. We only have an idea of what we will have. Well, in order to test this, we can use CDK matchers. And let's see how we can do this. Let's open our test file. Well, we are inside our test file, and let's test the SNS subscription. So I will test right here, SNS subscription. I will test the SNS subscription. And with this test, we can see how we can test for dynamic values. As I said, well, first of all, we want to query for a SNS subscription. So right here, we will call again monitor stack template has resource properties, AWS SNS subscription, but we will wrap this properties object that we are passing inside a CDK matcher. So right here, let's make some room right here, and we will use a match import from CDK. Make sure that you are using the right import. We are using the match import, and the function that we will use is object equals. This is the one, and now we will put our properties inside this match object equals function. All right, and now we can put exactly what we are concerned. Let's format this nicely. All right, and what we are concerned right here, let's check for this topic ARN, which gets a dynamic reference, and also this endpoint, which calls a CloudFormation intrinsic function with this webhook Lambda and also this dynamic part. Well, how we can write these tests? First of all, we can test for this protocol, and this protocol is lambda, so no dynamic part right here. Let me also put this right here. So this entry should have a protocol entry, and now we can check for this topic ARN. So we need a topic ARN. First of all, this receives a ref entry, and now the fun part begins. Because this ref entry right here receives a part that we specify ourselves, the name of the topic, alarm topic, and a generated part. How we can link these two together? Well, we can link by using a method. Let me make things more clearer. I'm using a big font. This means that it's sometimes hard to fit everything in the screen. So we will use again the match class, and we will use the method string like regular expression. And we want to assert for a string which contains this part that we know beforehand, this alarm topic name. Well, like here, and now we are asserting for a reference which contains this alarm topic name that we are sure to be present right there. And the same we can do with this endpoint. It has a function that is generated, that is specified by us, this webhook lambda, and also a dynamic part. So we can also specify for an endpoint. This endpoint is an object. First of all, the first entry is this fn get at right here. This is an array. And again, we can enter first of all this dynamic part with still match string like. I will just copy paste because I'm lazy. Match string like, and we want this to contain webhook lambda. And also don't forget that this is an array and it also contains ARN, like this. Let's see if this test is working. Alright, this test is also working. That's great. So we saw until now how we can test for dynamic values using CDK matchers. They are a great way to test these dynamic generated functions from CDK, because sometimes, most of the time, we won't know exactly what we can test against, and for this we can use matchers. There are multiple methods inside these matchers. You can also explore them by yourself. I will say right here in the description of this test, matchers, but let me tell you, we can also do this without matchers. Even if those are randomly generated values, we can still test them. And I will show you how. I will just copy this test. We will test for the same thing, but this time with exact values. And don't think for 1 second that I will just hard code these values inside the test. Well, I could do this. I would just hard code these values inside the test, and locally this test will work, but we can't say what will be inside the future. So we won't do it like this. Well, but how we can get the dynamic value inside this test? First of all, let's find the resource. Let's find this topic resource. So here I'll say const SNS topic. Let's query for this topic, and we can query for this topic inside the monitor stack template. We can find the resource. This is the one, and we need this AWS SNS topic. AWS SNS topic right here, and we can actually get its right value. So here I'll say SNS topic name directly taken from the template is our SNS topic. Or maybe to make things more clearer, let's just first print this SNS topic object right here. I don't want to make things too complicated. Let's just print this object right here. Let me delete this. Let's just see how this is working. And let's only run this test. I will say here test only. Let's only run this test to see how this SNS topic looks like under the hood. So here npm test. Alright, and we got this SNS topic, and as you can see in the console, we can get dynamically its name, and we can also get the topic. We can also make assertions just like we did in the previous tests. But as you can see, this is an entry. This is a JSON object. This means that we can dynamically take its value. How we can do this? Using some internal JavaScript functions, nothing too complicated. So here I'll say const SNS topic name is our SNS topic, or we can just say here object keys, and we are getting this SNS topic, and we just take the first value. And this entry right here will get the keys of this object and we'll get the first value. This is the one, and this way we know the name of the SNS topic. This means that we have everything we need. The same we can do with the lambda name. The lambda name that we were checking upstairs right here, we can do exactly the same with it. So let's also get its name. Let me copy and paste this. And here I will say lambda, const lambda is our monitor stack template find resource AWS lambda function. This is the one. And the same way we can get the lambda name, like here, with the lambda name and lambda name. And then we can make the same assertions, but without matchers, but with exact values. And because I'm lazy, I will just copy paste this code. Right here, we can make the same assertions, but without this match object equals right here, but directly with the exact values. So this is our ref, the SNS topic name, and as a matcher right here, our endpoint would be the lambda name. Let's see if this test is also working. All right, and all our tests are working just fine. That's great. As you can see, we saw in this lecture how we can use matchers for values that we don't exactly know how will be. We just have a slight idea, or we can even better use directly the name by using some JavaScript simple functions to get these object keys and use them directly as references inside our assertions. Let's move on into the next lecture and talk about another great testing utility from CDK, the Captors. Let's look again at our generated stack template, and let's look at this AWS CloudWatch alarm. As you can see, this is a complex object because it has multiple parameters, but is there a way in which we can get not only the object but also a particular entry inside this object? For example, we can take the alarm actions and make queries against it. Yes, there is, and in this lecture we will talk about a cool feature of CDK testing, and that is the captures. And let's go to our test. Let's see another way in which we can test. Let's write a new test, and here I'll say test, and let's just test alarm actions like this. And first of all, let's get the resource with has resource properties. So here I'll say monitor stack template has resource properties. First of all, we want to query for our alarm, and this is the value, AWS CloudWatch alarm. Let's query for it. And as properties, we want to directly take the alarm actions object right here, and like this. And now here we can pass something called a CDK capture. So let me save it upstairs. So here I'll say const alarm actions capture is a new capture from CDK assertions. This is the one. And I will pass this capture as a value for these alarm actions. And what this has resource properties will do, well, it will not assert things anymore, but in the same time, it will populate this alarm actions capture with the values of this alarm actions entry inside our CloudWatch alarm. Well, and at this point, we can use this alarm actions capture object to make assertions the way we are used to with Jest or with other testing libraries. Maybe we can use something like expect from Jest. We can use this alarm actions capture, and we can take this as array because this will return, if we look at the stack, it will return an array with an object. So we can take it as array right here. And since this is array, we can call to equal. First of all, let's pass an array and let's pass an object. And now this object should have a ref entry. And again, since we are learning, we can directly take the name. We can use CDK matchers, or we can use matchers from Jest. Let's use also a matcher from Jest to also understand better how Jest is working. And here we can expect something like string matching. And this is the first time we will use something specific to Jest inside this course. And let's say that we want these alarm actions to contain our alarm name. Like this. And this string matching requires a regular expression. So here I will just directly pass a regular expression like this. And now we are expecting that our alarm capture entry will have this alarm topic name right here. Let's see if this test is working. Well, the test is also working, that's great. So we saw in this shorter lecture how we can use another feature of CDK, the captures, which let us write more clear code, and we can use that code to make assertions the way we are used to with different testing libraries. Let's move on into the next lecture and talk about another way in which we can test our code by using snapshots. Let's now talk in this lecture about yet another way in which we can test our CDK code, and we are talking about snapshot testing. And this is something specific to Jest. We will use a feature specific to Jest, not to CDK, but which CDK in its documentation embraces and even recommends. Snapshot testing is a cheap and easy way to test our code. Its advantage is that it's cheap and quick. Its disadvantage is that it's cheap and quick. And what I mean by that? Well, let's write another test. And let's call right here this test. Let's move this upstairs. Monitor stack snapshot test. Like this. And this test will contain only one line of code. We can just expect. We can directly pass an expect. And here we can pass our monitor stack template to JSON. And we will call the method to match snapshot. This is the one. This is our simple test, which will test all our template. And this to match snapshot entry can receive any JavaScript object. Let's run this test. Let me run only this test to make this point a little better. So I will only run this test, and you will see how it is working. Let's pay attention to the messages inside the console. Alright, and our test was run, and as you can see, here we are getting the message, one snapshot written. So the very first time when we are running this test, it will generate a snapshot. And very importantly, this snapshot should be not added to git ignore, but it should be committed, and now this is part of our testing suite. Without this snapshot, this test would be just useless, because every time it will run, it will just generate another file and it won't check anything. Now the test will just look inside the snapshots entry right here, and this will create a snap entry, which will just be a exact copy of our JSON object that we pass right here. Now we can run the test one more time. This time it won't write the snapshot anymore, but it will just check against the existing snapshot our code. Let's see how it is working. Alright, and our test passed, and let's see what happens if we, for example, have a typo inside or not a typo, but a modification inside our stack. Let's run the test again, and this time the test fails. And as you can see, it will exactly tell us what was wrong. It was expecting this value, but received this value. So you might say that this is a very quick and efficient way to write and to test our stack, and that's true. But in the same time, we want to write our tests to be resistant to change. So in order, if we change something, we should make sure that we didn't break anything. Well, this is a quick way in which we can test, and I'm not very confident in having tests, unit tests, snapshot tests, which are also testing against a lot of randomly generated things. This is my only problem with the snapshot tests for CDK. What we can do, we can take other tests and also make our objects smaller. For example, we can test, maybe just let me copy this code, remove the only, and maybe we can just directly only take the lambda snapshot test, and we can directly take the lambda. How we can do this? Well, first of all, let's save it to a console. So here save const lambda is our monitor stack template. We can find the resource, and let's just pass right here our lambda function. Our lambda function right here. And now we can expect that our lambda should match the snapshot. And the advantage of this approach is that our checks will be much smaller. And in case something goes wrong, not the whole snapshot will fail, but we will have a better way to check if in case things are working bad. And the same thing we can do with other constructs, maybe with our SNS topic. So the same with SNS topic. Here we can pass the SNS topic, and we can run now our code. And now, as you can see, we have two new snapshots. These snapshots are a little small, so they are easier to check in case something goes wrong. If we look at our snapshots file, now this snapshots file will also contain a mirror of our whole snapshot. But as you can see, we have this snapshot 1 right here. And if we go downstairs, we have a snapshot 2 right here, and this snapshot stack right here. And these snapshots are much easier to track down. As I said, snapshot testing is a quick and cheap way to test our code. In my opinion, is not the best way, but it has a great advantage. It is fast to implement. So we reached the end of the video, the occasion for me to say thanks for watching. I hope that the points made in this video will help you improve your work. And I also want to end by saying like and subscribe, and the usual people say at the end of YouTube videos. I remember you that there's a full CDK course and in the description of this video. And this being said, I thank you again. I wish you all the best in your career and in your life, and also have a great day.